Hey math kids, today we're going to talk about finding a quadratic from its graph. And let's get started. So find the equation of the quadratic with these graphs. Alright, so they give us a y-intercept at -1, or sorry, an x-intercept, and then a y-intercept at 3, and another x-intercept at 3. Okay, so if you're ever given the x-intercepts, that's the best place to start. So we know it's x plus 1 and x minus 3. You're always going to change the signs when you put it into factored form. And we know that there could be a scale factor right here. Okay. Now, to find that scale factor, we're going to use the y-intercept. And so the y-intercept, x equals 0 when y anywhere on this y-axis, right? And so we're going to say that y equals 3 when x equals 0. Okay, we simplify this, it's a 1. Simplify this, it's a -3. Still have our a, still have our 3. So if we multiply this out, we get -3a equals 3. Divide by -3, so -1 equals a. Come back up here, and we can write our final answer as y equals -1, x plus 1, x minus 3, and that is the equation of this orange graph. Okay, let's try another one that's like that. So this time we have this graph, crosses the y-axis at 8, and it just kisses at 2 on the x-axis. Okay, so what that's going to do, once again, we're given both roots, and so we're just going to have x minus 2 times x minus 2, or x minus 2 squared. Once again, we have a scale factor out in front, and so we start with that. Now we take the y-intercept, and we know that's going to occur when x equals 0. So we plug in a 0 for x. And so we get x -2 squared, which is going to be +4. And then we divide by 4. We see that a equals 2. And so we just come back up here. We say y equals 2, quantity x minus 2 squared. Okay, and that's all we need to do on that one. So this equation is the right equation for this graph. Okay, let's keep moving on. Okay, this time we have a graph that looks like this. We have an x-intercept at -2. We have a y-intercept at 16. We know that the axis of symmetry is at x equals 1. We don't know what this is. Okay, so because we have the axis of symmetry, though, we can find this x-intercept, and that's what I'd suggest doing, because this is the halfway point between the two x-intercepts. And so to go this distance from here to here, that's going to be 3. And so that means the distance from here to here also needs to be 3. So -2 to 1 is 3 units, and so 1 to whatever this is needs to be 3 units. So we know that that's 4, because 1 plus 3 would be 4. Now we can pretty much approach this the same way that we were doing the other one. Just make sure you change your signs, so -2 becomes +2, +4 becomes -4. Once again, we have a scale factor out in front, and now we're going to use the 16 to figure out what a is. So we do 16 equals a, 0 plus 2, 0 minus 4. If we get rid of those zeros, we get 16 equals a times 2 times negative 4. We get 16 equals negative 8a. Divide by negative 8, divide by negative 8, and then a equals negative 2. And so we just rewrite this thing. Y equals negative 2, x plus 2, x minus 4, and that's our final answer for that one. Okay, let's keep moving on. Okay, it says find the equation of the quadratic whose graph cuts the x-axis at, so it gives us x-intercepts, 4, negative 3, and which passes through the point 2, negative 20. Give your answer in the form y equals ax squared plus bx plus c. Okay. So a couple things we can do. We can set up a mock equation. So just like we were doing on those other ones, we change the signs from the x-intercepts. We know there's an a. We know this is about what our equation is going to look like. Now this is a little bit different because it's not a y-intercept, but we're going to treat it pretty much the same way. So we're going to plug in 2 for x and then negative 20 for y. So negative 20 equals a, 2 minus 4, 2 plus 3. So this one becomes negative 2. This one becomes 5. So if we multiply those, we get negative 10a, negative 20, divided by negative 10. So a equals 2. So we plug in a 2 here. So y equals 2, x minus 4, x plus 3. Now in the previous problems, we would have stopped there, but they specifically ask us to put it in this form. So that means we need to multiply it out. So I'm going to ignore the 2 just for a second and do the distribution like this. So x times x is x squared, x times 3 plus 3x minus 4x, and minus 12. Now all of this is still multiplied by 2. I'm going to combine like terms in the middle before I distribute that 2. Now I'm going to distribute the 2. 2x squared minus 2x minus 24, and that's equal to y. And that is in the right form right there. And so we're done. Okay, we got another one. This time we're given this graph. Let's see, it crosses at 16 right there. And then we're given the vertex is 3, negative 2. So we don't know the x-intercept, but that's okay. Okay, so we're going to have to write it in vertex form first. So it's y equals a x minus h squared plus k. And to do that, we're going to say y equals a x minus 3 and then minus 2. Notice that this one, the sign changes, but this one, the sign stays the same. That's because of the minus sign. So we're basically multiplying this by a negative 1 when we put it in here. This is a plus sign, so we can just write it exactly how it shows up. Okay. Now we're basically going to use that. We're going to use that same trick. We got a y-intercept, so we're going to say 16 equals a, 0 minus 3 squared minus 2. Plug in a 0 for x, plug in a 16. Another way you can think of this is that point is actually 0, 16. And so we're just plugging in 0 for x when y equals 16. Okay, now we just need to solve for a to figure out what we have. So this is going to be negative 3 squared, still got our a. Okay, negative 3 squared is going to be 9. And so this is 9a minus 2. And we add 2, So we get 18 equals 9a, divided by 9. And so a equals 2. That seems to be showing up a lot. Okay, so now we come back to this. We just plug in a 2 for our a. And that is the equation of that green graph. Alright, let's go up here, get some space. Okay. We have another one. This time we have a graph that looks like this. We know the vertex is at negative 4, 2. We know one of the x-intercepts is negative 2. We do not know these two spots. Okay, now, because the vertex is at negative 4, we know that the axis of symmetry is negative 4. So we know that there are 2 units away from this, so there must be 2 units away from this. So this must be negative 6. Now that's a good starting spot for this. We also know the vertex though. So actually I didn't need to do that, but oh well. Maybe I did. We'll see. So y equals a, once again, vertex form, x plus 4 and then plus 2. Once again, change the sign on the x, do not change the sign on the y. Okay, I didn't need to know that other x-intercept, but whatever. That was just FYI, I guess. I'm going to use the original. What we're going to do is we're just going to use the x-intercept this time. So when x equals negative 2, y equals 0. And then just solve for a. So subtract 2. So negative 2 equals a. This is going to be positive 2. 2 squared is 4, so 4a equals negative 2. Divide by 4. Divide by 4, so that's negative 1/2. Is what a is equal to. Come back up here. Y equals negative 1/2. And then x plus 4 squared plus 2. And that is the equation of that. If you need additional help, please come to Math Lab. Until then, calculator.